Hello friends, let us now learn some important points about the Compton scattering. Almost all scattered radiation that encounters in diagnostic radiology comes from Compton scattering. So it contributes to all scattered radiation. So in this diagram, this is an atom with nucleus surrounded by electrons in its respective orbitals. When an incident photon with relatively high energy strikes the free outer shell electron, this free outer shell electron is ejected from its orbital. So, when it strikes the outer shell electron, the free outer shell electron is ejected from its orbit and the photon is deflected. So, the photon travels in a new direction as scattered radiation. The photon always retains a part of its original energy and the electron travels in an electron is ejected, and this electron which is ejected is called as recoil electron. So this Compton reaction will produces an ion pair which is a recoil electron, a positive ion, and scatter radiation or negative ion. The energy of the incident photon is distributed in two ways. One, the energy of incident photon, a part of the energy of incident photon goes to the recoil electron as kinetic energy, and the rest of the high energy the rest of the energy of the incident photon is retained by the deflected photon. Unlike photoelectric reaction in which most of the photon energy is given to the photoelectron from its bond, in Compton reaction no energy is needed for this purpose because the recoil electron is in the outer shell and it is already free. The incident photon always retains some amount of initial or original energy. There are two factors which determine the amount of energy that the photon recoils. That is the initial energy and the other angle of deflection of the recoil electron. This angle of deflection is theta, which is given as angle of photon deflection. So, in the Compton reaction, we have a recoil electron, a scattered photon or a characteristic radiation, and a positive ion. So, we have learnt about the energy difference also. Now, the important thing is about this recoil electron. So, this high energy photon will strike the free or outer shell electron, and thus the most of its energy is transferred to the scattered photon, and recoil electron has kinetic energy. Then the factors that determine the outcome of energy which the photon retains. There are two factors, one the initial energy and the kinetic energy, initial energy and the angle of deflection. There are two factors which determine the amount of energy that the photon retains. One the initial energy and the other angle of deflection of recoil. So, if you see the angle of deflection or recoil, for example, 75 kilo electron volts photon retains as it is deflected through various angles. So, if you see when it is deflected to 0 degrees, that is almost no deflection, the photon retains most of its energy. If it is deflected to 30 degrees, the photon retains a little, loses only a small amount of energy. So, if you keep on seeing on increasing the angle of deflection, the energy, more energy is lost. So, as the angle of deflection increases, more energy is lost by the X-ray photon. So, first, so that is one thing. Next, this wavelength of the scattered photon, there is, so with lower energy radiation, fewer scattered photons. So, with lower energy radiation, fewer photons scatter forward and more photons scatter backward. So, we have to calculate the formula or wavelength for calculating the change in wavelength of the scattered photon. Change in wavelength, which is given by delta lambda, is equal to 0.024 into 1 minus cos theta. Before we go this, one thing we have to see is that narrower the angle of deflection, photon retains the original energy. Thus, there is increased fogging of the rays. X-rays. Higher the scattered radiation, higher energy, the scattered radiation is not removed by filter or grids. See, there are two important things. We have said the X-ray photon, according to the angle of deflection, it retains some of the energy. So, if you see, the distance from the point of interaction is used point of interaction is used to express the percentage of scattered photons in varying angle. So, if you see here, with lower energy radiation like 70 kilo electron volts or 100 kilo electron volts, fewer photons will scatter forward and more photons scatter back at an angle of 180 degrees. Fewer photons will scatter forward, whereas more photons will scatter backward at an angle of 180 degrees. This distribution is fairly constant throughout the diagnostic energy range. Second point. Next. So, if in diagnostic energy range up to 150 kilo electron volts, photons will retain most of its energy and very little energy is transferred to the recoil electron. So, photons retain very little energy, meaning that the angle of deflection is narrower. At narrow angle of deflection, the scattered photons retain almost all of their original energy. This creates a serious problems in diagnostic radiology because these photons that are scattered at narrow angles have excellent chance of reaching the X-ray film and they produce fogging of X-rays. They are exceedingly difficult to remove from the X-ray beam. In fact, they cannot be removed by filters because they are too energetic. Because of its high energy, they cannot be removed by filters and they cannot be removed by grids because their angle of deflection is too small. Because we have no way of removing them from the useful beam, we must accept them and tolerate an image of diminished quality. Scattered radiation from Compton reaction is a major safety hazard also. Even after the photon has been deflected by 90 degrees, it still retains most of the energy because energy here is 75, energy here is 66. Even if the photon is deflected by 90 degrees, it retains most of its energy. This means scattered radiation that arises in the patient during fluoroscopic examination is almost as energetic as the primary beam. It creates a real safety hazard for fluoroscopists and other personnel who must be in exposure rooms. So, this is the important thing about the scattered radiation, where angle of deflection is very, very important. And we have seen what happens for different angle of incidence, angle of deflection angle, and what happens for the energy rays. The next thing is calculation of scattered photons. For calculation of scattered photons, there is a formula. Change in wavelength is equal to 0.024 into 1 minus cos theta, where theta is the angle of deflection and delta lambda is the change in wavelength. Similarly, we can also give a formula for energy of photon. Energy of photon, which is kilo electron volts, is given as 12.4 by lambda, which is wavelength of the photon. Then the next important thing is probability of occurrence of Compton reaction. The probability of occurrence of Compton reaction depends on the total number of electrons in an absorber. This total number of electrons in the absorber in turn depends upon the density of the element and the number of electrons per gram. All elements contain approximately same number of electrons per gram regardless of their atomic number. Therefore, the number of Compton reactions is independent of atomic number of absorber. Whereas the photoelectric effect depends upon the atomic number of absorber. The likelihood of of this reaction, however, this depends on the energy of radiation and the density of the absorber. The number of reactions gradually diminishes as the photon energy increases, so that high energy photons are more likely to pass through the body than the low energy photons. Because the Compton reaction occurs with free electrons, we must define the term free electrons little more precisely. An electron is considered as free electrons when the binding energy is great deal less than the energy of the incident photon. If the binding energy is very less than the energy of incident photon, then we call the energy electron as free electron. With the photon energies used in diagnostic radiology, only outer shell electrons are considered as free electrons. But in high atomic number, if the elements have higher atomic number, the outer shell electrons are considered as free electrons. Whereas for elements with low atomic numbers, those found in soft tissues, all electrons are considered as free electrons, because even those low in atomic number, in elements with low atomic number, even the K shell binding energy or the electrons in K shell are bound with energies less than 1 kilo electron volt. So this is the important points about photoelectric effect. In the next, sorry, about Compton reaction. In the next class we will learn about pair production and photo disintegration. Thank you.